Okay. Hi. Good afternoon, everyone. Welcome to Fit 5136, and we are on week 9 already. Today, we're gonna cover the topics about black box software testing. All right. So basically, last week we talked about the unit testing, test coverage, and we just talked about how to write the test cases and execute it. Right. But in reality, sometimes we have, let's say, if we apply the test-driven development, we haven't started writing the code, and then we're gonna treat the software as a black box, right? So there are a bunch of the techniques based on the given software, based on the given requirement specification. How should we create the test cases based on that kind of requirement? Okay, so we're gonna cover that kind of topic. How can we test the software without knowing what is actually inside the code? Okay, that's the point. All right. Just a brief high level about the software testing. Basically, it is a process of evaluating or verifying whether your software product or application does what it is supposed to do or not. Okay, so there is a bunch of the software testing technique. Okay, so the first one, if you look at the figure on the right here, okay, based on the software testing taxonomy, there are two ways that you can test the software system. Okay, first one is the dynamic or the static. Dynamic, the key point is that you actually execute the code, okay, execute the test, and then see the behavior. All right. If you want to test the software statically, okay, it means that you actually conduct the code review. So, or you inspect the code, you read the code, you don't execute anything at all, okay, just look at the code itself and then try to find the bugs. So most of the technique in the static way, you can do code review, code inspection, that kind of thing. All right. However, the topic of today's lecture is really about the dynamic part where we need to write the test cases and then we're gonna execute it, that kind of thing. Okay. However, as I mentioned to you that we can create the test cases based on the requirement or based on the code as well. Today, we're going to talk about the black box software testing, which is really based on the specification or the requirement. And the next week, week 10, we're going to cover the topics about white box software testing. All right. Where we know, where we see the code, how many lines are there, and then we want to check whether we actually cover everything or not. Okay. Uh, so black box is really more like system testing or the UAT, user acceptance testing, right? You have the high level requirement. You can test at the system level, test at the user acceptance testing level as well. Like um, think about the calculator. Okay, calculator should be able to do some mathematical operations with blah 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 that kind of thing, and then you come up with the equation or the formula, and then that's the black box. Okay, you come up with something, and then based on the requirement. Okay. Um. Yep. So that's the software testing. Okay. And yeah, as I told you before, and today we're gonna cover, as I told you, we're gonna talk about the black box software testing. We're gonna talk about the why do we need to select the test cases? How do we come up with the test cases so that it is optimal? How can we what is the random testing, what is the equivalence partitioning, what is the boundary value analysis. So we're gonna talk about that as well. All right. Okay, the difference between the white box and the black box is that when you do the white box, you actually see the code inside. This is a if something and then else something. Okay. Um, However, when you test the black box, do the black box testing, you actually don't know what is the code inside. The code doesn't happen, but you need to come up with the test cases based on the requirement. Okay, that's a pros and con. All right. That's a pros and cons. It doesn't mean that one is better than the other. Okay. So yeah, black box, as I told you, we're gonna test the functionality of the software or system or application without having access to the source code at all. You need to think about the behavior of the application or the software. What would be the expected what would be the input, okay, the test input, and what would be the expected output, All right. Let's say you want to test the addition function without knowing the return a plus b. You can actually derive the test cases that 1 plus 1 it should equal 2 or 2 plus 2 it should equal 4. All right. Okay. The difference or why or whether the pros and the cons of the white box and the black box software testing. Okay. Let's think about this one. Do we need both or not? Okay. Let's say this is a requirement from the customer, all right? From the client, you write the specification here. Let's say you want to build a calculator application, all right? Calculator application, you may you know that it should have the addition function, okay? Addition operation, it should have minus, okay? It should have multiplication or the division, all right? Or the division. Okay, let's say you already implement, okay? You already implement plus and the minus, okay? You implement everything, okay? What is that? Sorry. Yeah, multiplication and division, all right? Okay. Um, However, I actually, okay, this one is not a good example. Let's say you have, based on the requirement, you implement plus minus, okay, multiplication, division, and then the last one is the square root, all right? So when you implement plus minus, okay, multiplication and the division, right? If you do the black box software testing, you already know that there are 5 features here. However, the square root is missing, right? So that's a missing functionality. What do you actually implement is plus, minus, multiplication, and the division, okay? So that's why if you apply the black box software testing, you review the requirement, and then you can come up with what is the missing functionality, okay? But when you implement the plus minus multiplication and the division, when you look into the code, right, you may have the what is that? Some unexpected functionality. Let's say you know that with the division, we need to handle the division by zero. Okay, in mathematics we cannot divide by zero, so this could be the unexpected functionality, right? So that's why you need to implement, like, let's say if and else something, okay? And then if the division is by zero, then you need to throw the errors or print a message that the our calculator cannot divide by zero, something like that. So that means, okay, to identify the missing functionality, you need the black box software testing technique. If you want to identify the unexpected behavior or the unexpected functionality, you need the white box software testing technique. Okay. All right. Uh, Question is that, can we test the division by zero in the black box testing as well? Yes, definitely. It doesn't mean that you need to test the division by one approach or another. Okay, you can do both, but at the end of the day, it's about uh, when you look at the requirement. This is more like a requirement coverage. Have we implement all of the requirements? Have we implement all of the features or not? Have we implement all of the functionalities or not? However, for each of the functionalities, we also need to think about the unexpected behavior as well. So that's why both of the testing technique, they are complementary. No matter what technique do you use, whether you use black box, you use white box, you need to write the unit test anyway. Okay, so that's the same output, the same artifact. It depends on which phase or which technique you want to apply in order to come up with that kind of test cases. Okay. The next question is that from the Zoom chat. Does this imply that black box testing are mostly manual testing? Not really. Okay. So not really. How can I say manual testing? Manual in terms of what? Okay. Manually created? Yes. Okay. Manually executed? No. Because when you use the black box software testing technique, we need to write the unit test anyway, and then it can be automatically test, run the just PyTest command, and then it will just, run the test suite automatically. Okay. So it doesn't mean that, yeah, black box testing is actually manual. We need to manually create it, but to execute it, it can be automatic as well. Very good question. Thank you so much. All right. So just want to recall a little bit again. What exactly is a test case? What are the components? Okay. Uh, the original, fundamentally, sorry. Okay, fundamentally, what do you really need is the test input, okay? And the test oracle is the expected output, all right? This is the two key component as part of the unit test. If you remember, if you assert, assert, let's say assert equal, you want to uh, assert whether the something, okay, expected output, no, sorry, the actual output is the same as the expected output or not, okay? That's the assertion function, all right, in Python. So if you don't know what is the test assertion, go back to the previous lecture immediately, all right? Okay. Um, Next, all right. Okay, black box testing approach. There are a bunch of the approaches. Okay, the first one is the exploratory testing. It is manual. It's not systematic at all. It doesn't mean that you're gonna create test cases that are most efficient and most effective. Okay, so this is just like the basic approach. Using exploratory testing, you can find defects as well. It requires the domain knowledge. Okay, to come up with this. Test cases, okay? But it's not systematic. The next question, how can we make it more systematic, right? Okay, no, okay, not yet, okay. The slide after this one, okay. So let's do some activity together. Let's say we want to test a summation function, right? The problem is that the problem for this one, we want to test a summation function that takes two integers. So let's say if we may implement, define a function sum that takes to integer a and the integer b. All right. Easy. Okay. You may think that, yeah, the expected input could be that, 1 plus 1 equal 2, 0 plus 0 equals 0, 2 plus 3 equal 5, minus 1 plus minus 1 equal minus 2, right? When you come up with this kind of test cases, we call exploratory testing. Okay, we didn't apply the systematic or domain knowledge or which values that we should really test it. Or someone or some student may come up with another test case, right? Like 10 plus 10 equal 20, 20 plus 20 equal 40. And then because the integer range, okay, the space of the integer is the 2 to the 32, okay? That means the numbers of the possible test input with this summation function here could be like 2 to the power of the 64, and that's like over billion, over like, I don't know the number here, okay? 10 to the power of the 54. That's like, there are 54 of the zero here, okay? That's a possible test input. And then because of the large input space, all right, because of the large input space, in real world we cannot test like such kind of billion test cases, right? Because we have limited budget. We need to release the software, let's say this calculator application tomorrow, all right? Then many of the test cases are really redundant, okay? They are falling into the same scenario. There's a positive range. Then why do we need everything? So that's why we need to learn the more systematic technique to create the test cases. Okay. So let's suppose that what is that, this spec, okay, include 20 inputs, each with four possible values. Then it will be 4 to the power of the 20 possible test cases already. Let's say each test case takes 30 seconds to run. Basically, we take like more than 1 million years, okay? So in reality, as I mentioned to you, it's not feasible to test all of the test cases. we cannot run exhaustively tests. Okay, we cannot do it because due to the time and the resource constraint. Then when we say effective test cases, it means we need to run the smallest numbers of the test cases that achieve the highest code coverage. Okay? Okay? So that's we call effective. We don't want redundant test cases at all. All right. So there are different ways to design the test cases, and then we will cover a few of them today. Okay? Random testing, uh, or people call fuzzing. Okay, fuzzing is another technique to randomly generate the test input. Okay, this is the idea when we don't know we like the goal of the fuzzing is that we want to test the randomly generate the input, test input, and test it until it crash. All right. Whenever the software crash, that's the bug. That's the goal of the fuzzing. Okay. But it is quite advanced. It is quite useful in the security testing. We will not cover in this lecture today. Okay. I just mentioned it. All right. But today we're gonna talk about the equivalence partitioning testing. Okay, that's the first technique that I really want or proudly present to every student here. Okay, all right. So let's read this one together. Equivalence partitioning testing is a black box testing technique used to design the test cases by dividing the input domain into the valid and the invalid equivalents, disjoint classes or partitions, and then you select the representative values from each class or partition to create the test cases. Okay, so again, okay, I'm gonna repeat again. The first step, you divide the input domain or the range into the valid equivalents, okay, valid invalid classes, and then for each of the class or the chunk, you come up with the representative test cases. Okay, let's do it. Okay, let's do it together. All right, Jim, you guys are so familiar with the gym eligibility. Okay, so the requirement here is that uh, it should return true if a person age which takes the integer, okay, is between 18 to 65, otherwise false. Okay, that's the 18 to 65 inclusive number. All right, the first step that I would need to do is to draw the range. All right, I think I have did this kind of thing before. Okay, into an equivalence or into the classes. Okay, so the range here is that with the age. Okay, so we're gonna focus on the 18 to 65. Based on the requirement, it should return true. All right, otherwise false. Okay, false. And with my domain knowledge is that the age cannot be lower than 0. Okay, that means how many classes that we're gonna have here? 4. Okay, the first one here, 2. Okay, 3. Okay, 3 partition and the 4 partition. And then for each of the partition, you come up with, okay, select the representative values that fall into the range here. Okay, so the first thing I'm gonna come up with the number that means anything that is less than 0. So I just say 5, oh, sorry, -5, which should return false. Okay, that's a false. Yeah, return false. And then I describe what is the test scenarios here. I test come up with this test case because the age cannot be negative. Okay, you need to justify the age and then any value between 0 to 18. Then I just randomly choose 10. Okay, and so far and so forth. All right, you get the idea. Okay, repeat again. Equivalence partitioning testing. Use come up with the range, okay, of the input domain, split into the partition, and then randomly select the representative test case. Okay. All right. Any questions so far, everyone? It sounds like boundary testing, but it's not boundary yet. Okay. This is just one step before the boundary value analysis. Okay. Okay. Let's we would another question, we would assume the input is valid int type. Not really, we cannot assume. Okay, so with this technique, to come up with a robust test suite, you need to apply different techniques together. Okay, like this one, we only focus on the positive where how can I say, positive test cases, where we only consider assume that the input is the integer. But if you think about the two, last week lecture, we talk about the negative scenarios, right? So ideally you should test, come up with the test cases with the other negative scenarios as well. For example, string input, you know, or a infinity number, I don't know, or the emoji, that kind of thing, or object, you know. So you can test it, right? Okay, there's no harm at all. So test as much as possible to make sure that your software system or the application is actually robust, okay, to the uh, weird behaviors here or unusual input. Okay. Yep. Yep. All right. Yep. Next, okay, David Jones discount campaign. Let's say the spec here is that it should return discount 5%, okay? If purchase over 100, or 10% if purchase over 200, or 20% if purchase over 500, or zero otherwise, okay? Right now, I'm gonna come up with the test cases without what? Without knowing how to implement the code at all. I didn't do implement anything, okay? But I can come up with the test cases. Yeah, but that means the spec should be very clear, okay? So the input domain is the purchase amount, right? Okay, and then based on the spec here, we want to say that, okay, what is that? Return 5% if purchase over 100, but between 200, so it returned 5% here. That's the first partition. 10% if over 200, okay, then what is that? So here it should be 10%, all right? uh, or 20%, okay, if purchase over 500, okay, so that's a 20%, or 0% otherwise, okay. Yeah, so with this one, I know that the input domain is the purchase amount. I create the partition or the classes here. So I have how many classes? One, okay, two, three, four, okay, all right. Or the input amount should not be less than zero as well. So I should have another one. Okay, let's say one here. Okay. So in total, there will be five. Okay, five partition. Okay. So for each of the partition, then I just randomly, select the values. Okay, to represent that class. Okay, it's like you come up with the test scenarios, but with this kind of equivalence partitioning testing, okay, it helps you define how many possible test scenarios that it should be, all right, based on this specification. So these are the test scenarios, you just describe, and then you just come up with the test cases, and then there we go, you have like at least five test cases that you should test, okay, for this spec. Okay. Yeah. Any questions? Yeah, with this one? I hope not. Yeah. Okay, let's move on. Now, next one. Okay. No one really want to get sick. Okay, so we're gonna build a thermometer, to check your temperature, whether you catch a cold or not. Okay, and the temp function. Okay, again, this is just only the specification. We don't have any code here. All right, but the first step is that what is the input domain? That's the temperature. Temp, okay? And then what is the range or the partition here? We have 36.5. We have 37.5. So anything below, okay, below 36.5, it should be blue. Between is the yellow, and then red here. All right. So once you come up with the partition, again, you just define the test scenarios. You have three scenarios that you should test, and then you just come up with the test scenarios and come up with the test cases. Okay, easy. All right. Okay, this one is hard. Leap year. Does anyone know leap year? Okay. Leap year, okay, is the definition here is that each leap year has 366 days, okay, instead of 365. Okay. Normally, one year we have 365 days, okay. Only the leap year that has 366. And by extending Feb to 29 days, okay, rather than the common 28 days. That's the common definitions of the leap year. All right. So based on the specification to know whether this is a leap year or not, okay, we're gonna create this kind of function. With this function, all right, leap year will return true if it is divisible by 4, okay, unless it is a century or divisible by 100, okay. For any century years or divisible by 100, they are leap years only if they are divisible by 400. Otherwise, false. Okay. All right. The definition here is really difficult. Okay. It's a bit complicated, but let's break it down together. All right. Let's test your domain knowledge. So what we are going to do is to test the what? Do the exploratory testing. Because right now, the spec here is too complicated, right? How can we break down or test systematically? Really difficult. All right. Let's explore something together. Test your thinking. So if we think about whether the 2000 is a leap year or not, okay. This one is considered as leap year because it is divisible by 400. First of all, it is, what is that? Okay. Leap year return true if it is divisible by 4. Okay. Otherwise, it's not leap year. Okay. But if it is a century years, okay, they are leap years only if they are divisible by 400. So that's this spec. Okay. So that's why this one fall into this sentence here. All right. What about 1900? 1900, is it divisible by 4? Yes, it is divisible by 4. Okay. And also by 100 as well. Am I right? 1900, that's divisible by 100. But this one is not divisible by 400. Okay. So this one is false. All right. So it is not leap year. Make sense? Okay. Next one. Is leap year or not? 1964. It is leap year because it is divisible by 4. Okay. 2004. It is leap year because it is divisible by 4. Is leap year or not? 1965. It's not. It's not at all. Okay. Because it's not divisible by 4. Okay. Yeah. 2023. Is it leap year or not? It's not divisible by 4. No, it's not at all. Okay. Question to everyone. 2026. Is it leap year or not? Everyone, give me the answer in the Zoom chat. Yeah. And why? Yeah. Please. Yeah. Is it leap year or not? No? Okay. Why? Because it's not divisible by 4. Okay. All right. What about 2028? Is it leap year or not? What about 2028? Yes. Okay. Yeah. All right. Good. Good. Very good. Okay. So everyone have a clear understanding. Sometimes we can use the domain, use the exploratory testing to gain a better understanding of the domain knowledge here. All right, everyone understand what is a leap year. Now, because we don't know how to test, okay? But let's, cheat a little bit. Let's write some pseudo code here. Okay, if we write the pseudo code and then you will see the classes, okay? Yeah. So first of all, if it is divisible by 4, but if not divisible by 100, it will be true, okay? Otherwise, it should be divisible by 400, then it should return true, otherwise false. Otherwise, okay, false. Okay. Question to everyone. How many classes here? Okay. Can someone help me? How many classes? How many possible classes that we should test? Yeah. in the Zoom chat. Yeah. Anyone? No one? Okay. All right. Okay. So at least, okay, if we think about or use the equivalence classes, then it should be four classes for now. Okay. First one is here. Okay. Second one is here. Third one is here. Okay. And the fourth one is here. Okay. So once you know the scenarios, right, that there are four classes that we should test. Okay. The first one, what is that? Okay, that's the condition here. Divisible by 4, but not divisible by 100, and then it is considered as leap year. Okay, next one, divisible by 4, and then if divisible by 400 as well. Okay, yeah, and because of else here, right? So it is divisible by 4, by 100, and 400 as well. We consider as leap year, otherwise not leap year. Okay, that's a false here. Okay, and that's the last scenarios. Okay, not divisible by 4, then we're gonna consider as the non-leap year. Okay, basically, how many test cases do we have? Realistically, 4. Do we need everything in the previous slide? Okay, no. All right, let's take a look at this one, right? Whether we see four unique scenarios or not to reduce the redundant test cases as much as possible. Okay, so we have the first one, yes. Okay, number one, number two, number three. This one is redundant. This is number four, and this one is redundant. Magic. Okay, looks like exploratory testing. We can come up with lots of test cases, and then you can reduce it to, to be what? To be four scenarios. Okay? Yeah. Okay. Magic. That's a magic. Okay. All right. But if we look at the four scenarios here, is it enough, right? Okay. Let's take a look. Probably, okay. Once we have the scenarios, then you derive the test cases, implement the assert equal, that kind of thing in Python. Okay. All that. But is it enough? No, not yet. Okay. There are other classes as well. For example, it should include some examples of the invalid input, right? Like negative year. Yeah, the year cannot be negative because the year here we focus on the four digits number. Okay, then that means we should not take the five digits integer at all, right? If the year is 10,000, then yeah, we will not take that. If the year is the non-numeric numbers, okay, or alphabetical characters, okay, so it should return false or return something else. All right, okay, makes sense, everyone? Yeah. Okay, in summary, equivalence partition testing can be used to reduce a very large numbers of the test cases into a manageable chunks. You create a partition, okay? Like with the leap year, that's really complex. When you write the pseudocode, you may see that, okay, there are potential four classes, and then that's why you need only four test cases, okay? We don't need like 6, 7, 8, or 10 at all, right? And then sometimes you should consider the invalid input classes as well, or the negative scenarios, right? Whether if the input is something else, let's say Boolean value, true, false, that kind of thing. All right. That's all. Okay. The next step, I'm gonna teach you about the boundary value analysis. Okay. Uh, what happened is that uh, some study found that most of the bugs are found around the conditions of the boundaries. Okay, because if I put a less than or greater than without the equal, the implementation is already wrong. Okay, that's why we will learn about the boundary value analysis, which is more effective than the equivalence partitioning testing. All right. Okay, let's take a look. Okay, there are some terminologies: on point, off point, in point, out point, whatsoever. All right, let's take a look at the real example, and then you will understand much better. Okay, let's say what is this requirement here? We want to add a shipping cost if the price is less than or equal 100. All right. Yeah, you buy too little, okay? we need to add the shipping cost on top of the total price. Otherwise, I'm gonna the shop owner doesn't want to cover the shipping cost at all. All right. So what is the condition here? That means if the program, the condition used in the if statement here is that x is less than or equal 100. All right. So the on point that we are talking about here is called 100. By the definition, on point is 100, okay, which is the value in the condition. All right. And the on point makes the condition true, okay. Yeah, because if anything less than or equal 100, then it will be true, otherwise false, okay. So that means what we should test if you draw the line again, okay. In point means that's the valid scenarios, the positive scenarios, right? That return true, otherwise return false, okay? And then on point is the value at the condition, okay? That's the value at the condition with because the spec here say that 100 is the condition, it should below or equal 100, then that's the on point value. And then what you really want to test is the boundary value, the values that surround the on point values. Okay. So what you really want to test here should be, for example, 99, 101, 102, that kind of thing. All right. So this is what you really want to test. Okay. Not like something else. Okay. Not like 50. Okay. So we will not come up with the test cases random. Okay. That's why we really want to teach you this one. Okay. Yep. And what if I change the condition to just less than 100 without the equal. All right. Yeah. Now the on point is still the same because the on point is the values of the condition. But the difference is the in point here and the out point. In point means the valid number, which will return true, and the out point will return false. All right. With this one, okay, you want to say that the on point is 100, and again we want to test the boundary value, right? Sometimes we just missing the equal here. Yeah. So you want to test the 99, you want to test the 101 to make sure that it returns the values properly, okay, whether it is true or false, right? Okay. Yeah. Now let's say that, okay, if we focus on the less than 100, okay, this is what I told you already, that we should focus on the boundary values, okay. That means we want to test what is that, the boundary value around 100, okay. So 99 it should return true, 101 it should return what is that, false, right? And because of this one less than 100, this one should also return false as well. Okay. Yep. So make sense. Okay. Make sense. Yeah. Clean this slide. I think this one it should be false. Okay. Yep. Okay, so if you look at the range, all right, just clarify this one again. If you look at the range, the on point value is 100, and because of the requirement, we want to say that anything beyond 100 will return false. That's an off point, and the on point is here. All right, that will return true. Okay, so the first step that you really want to do is to find the maximum values that make the condition true. Okay, what would it be? That's a 99. Okay, that makes the condition true. And then if you really want to test okay, but if you change the x less than or equal 100 here, then yeah, okay, so that's the maximum. Okay. Yeah. So that's the maximum value. So let's say if we want to change the condition to x less than is less than or equal 100, then what do we really want to test? The maximum values that will make the condition false will become that the maximum values that make the condition true will become 100. Okay. Yeah. All right. Cool. Next one. Okay. We want to test, okay, group allocation, which that means we want to test whether this group is valid or not, right? That's a function, is group valid. Return accept if the minimum numbers of the student is equal 3, otherwise reject, okay? So what should we test here? The boundary value is 3. That's the value of the condition. We want to test the system with the 2 students that's below the limit, 3 students on the limit, and the 4 students above the limit. So these are the right 3 boundary values that we should test. Then once you come up with the test scenarios, then you create the test cases. Okay, is the group valid or not? The 2 students reject, 3 accept, 4 accept, that kind of thing. Okay. Next example, Monash letter grade. Okay, Monash letter grade. So let's say we want to come up with a function, all right, to convert the mark into the letter grade. That means based on your domain knowledge, we know that the mark range is range between 0 to 100. Okay, it cannot be negative, and it cannot be like 101 as well. All right, this is what you know. Okay, and the output will be the letter grade. Okay, so if I come up with the partition, let's say if I apply both techniques together, equivalence partition testing and the boundary value analysis, right? So basically, there are 5 partitions here. Make sense? Okay. We have partition N to partition HD. And then what do you really want to test is the boundary values around that partition. Okay. Because you know that the boundary value is 0, 49, 50, 59, 60, 69, 70, 79, 80, and 100. What I would test, okay, is to test around this number. All right. For example, -1, 0, and then I would test 1 as well. 48, 49, 50, 51, okay, 58, uh, and then because we're gonna test 59 anyway, 60, 61, okay, 68, 70, 71, 78, 81, yeah, and then 99, and I would test 101 as well. Okay, that will cover all of the boundary values of the decision point. Okay, make sense, everyone? Do you have any questions about the Monash letter grade? Any questions? Yeah. If not, yeah, let's move on. Looks like today we're gonna have like lots of examples, and I hope that everyone will enjoy and have a better understanding or deep understanding of the black box software testing. Okay. Example 8. Okay, now we're gonna design a game. Let's say we have a game, and the logic rule here is given the score of a player and its number of remaining lives. Okay, the program will does the following. All right, if the player score is less than 50 point. Okay, so the input here, what is that? Score. Okay, SCORE. Okay, and the remaining life, okay, let's say I put L. All right, so if the score is less than 50, let's say 49, then it always add 50 point on top of the current point. Okay, otherwise, if the remaining lives are greater than 3, it triples the score of the player. Okay, otherwise it adds 30 point to the current point. Wow. Okay, what is that? So complex logic here. Okay, so what is that? We have uh, if the player score is less than 50 point, it will add, okay, 50 points. So what is that? We have the score, and it will return, uh, if it is less than 50, then plus 50. Okay, otherwise, if remaining lives are greater than 3, it triples the score of the player. Okay, otherwise it add 30 points to the current point. Okay, so basically it return what is the point, the final point. Okay, all right. So how many partition here? All right. So based on this one, we're gonna draw the XY axis, right? Okay, maybe. Okay. So let's say we have the y-axis that consider the life, okay, and we have the x-axis that consider the score. All right. If what is that? Live, let's take a look at the point. Okay, so start with the first requirement. Score is less than 50 point. Okay, that's a point. Okay, that's a score 50. Okay, that's the on point. Otherwise, okay, score 49. What is that? Okay, score 49. Then this way, score 50 is this way, and then we're gonna look at the numbers of the what is that? Remaining lives. Okay. Okay, with the score less than 50 point, then it always plus 50 to the current point. Okay, so this one, all right, it always return plus 50. Make sense? Okay, regardless of the numbers of the lives. Okay, that's why it cover everything. However, when the score, okay, that's else. If the score is greater than or equal 50, then if the remaining lives is greater than 3, okay, now this one, okay, that's the remaining life greater than 3, it triples the score, okay, times 3. Otherwise, as at 30 point. Okay, that means if my score is 51 and I have a life or what is that equal to, I get 30 point in addition to the existing one. Okay, make sense, everyone? So how many test scenarios do we have here? Three, okay? I have two little point. I don't need to think about the remaining lives at all. I have, some point over 50, but little life. That's a scenario, another partition, and that's another partition, okay? When you draw this kind of analysis, it helps you to come up with or break down the scenarios. I mean, come up with the test scenarios really well, okay? So with this one, with these scenarios, how you should test it, how you should come up with the test cases, okay? So what I would do, right? Because the input is what the score and the remaining lives, okay? What I would do, you already have three test scenarios here. That means I would test 49, okay? Regardless of anything, okay? Another one, 50, okay? And the decision about the lives here is number 3, okay? Number 3, it will return what? Triples times 3, times 3, okay? Another test case, 50 and remaining lives. Okay, sorry, I did something wrong here. Okay, so for the second partition here, if the score is greater than or equal 50, but the remaining life is less than 3, let's say I put 2, I got triples of the score. But if I put the 3 here, okay, then what is that? Plus 30. Okay, make sense? And this one just return, okay, plus 50 point based on this requirement. Okay, make sense? Yeah. Okay. I cover everything. Okay. Based on that one, you come up with the boundary values and then you can extend. Okay. Extend with the boundary, extend the initial test cases with the using the boundary value analysis as well. Okay. Yeah. All right. Okay. Next example, credit card limit. Same, this one. We're gonna apply both equivalence partitioning and the boundary value analysis. All right. Okay. Based on this requirement, we gonna what is that? We want to check the credit card minimum credit card limit. Okay. So okay, this is a credit card application. That means we need normally when you apply for a credit card, you need to input the minimum credit card limit, and it will return true if it is over 100, otherwise false. Okay, so that's the minimum 500. That means the boundary value is 500. Let's draw this line. Okay, and you have 500 here. Okay, what I would test is 499, and another one is a 501. And because the credit limit cannot be less than zero, so I would have another uh, partition here. Okay, so how many partition do we have? One, okay, two, sorry, yeah, one, yeah, one, okay, two, yeah, is that correct? No, not really. One second. Yeah, anyway, we don't need to write down the classes, okay? But let's do the mapping, all right? Let's say the class one is between 0 equal to, sorry, if the amount is between 0 to 500, okay? That means what you really want to test. What is that? I get confused myself. Okay. Let me try again. Okay. Let me repeat again. So you have the range here, the domain input, which is the credit limit amount. All right. And then you partition. Okay. Let's forget about this one. So basically you have a few classes here. I would say five. All right. Five, four, five here. Okay. What you really want to test, okay? Anything below zero, it should return false. Anything between 0 to 499, it will return true, okay? Between, not between, but I mean, if it is 500, no, minimum credit limit, okay? It should not return true, it should return false, okay? And the 500, that's the on point value. It will return true, and the 501 will be true as well. So anything over than this will be true, okay? So it's not really the partition in the 4 and the 5. Okay. So, and then once you have the equivalence partition here, and then you come up with the test cases, right? Around 0, you might want to test the -1, okay? That's this one. 0, you want to test the 0, you want to test the 1 as well, or 2 as well. So all of these, it should return false, okay? Yeah. And then you have another value around 500, okay? You have 500 as a value in the middle, all right? So 500 will be true, but 1499, it will be false. 501, it will be true. And sometimes you can test the decimal numbers as well. You can test the non numbers as well. Okay, so that could be another classes that you may want to think about. So the class are like test scenarios, just the way to help you, to come up with the test scenarios. Okay, so question, is on point value testing a part of the boundary boundary testing? Yes. I mean, the the equivalence partitioning testing, the BVA, boundary value analysis, just a technique to think about how should we create the test cases, okay? And then both techniques may generate the same test cases. That's totally fine, okay? But the point is not about what is that? The point is not about which technique will test the 500, okay? It's not about that point, okay? So yeah, okay, all right, sorry. Back to your question, is on point testing a part of the boundary value testing? Yes, okay. So we want to test the on point value as well. Okay, that might be better. Otherwise, I will be overthinking. Okay. All right. So many of you have seen the gym eligibility from last week, and then someone asked me that, yeah, why don't we apply the equivalence partitioning or the boundary value analysis together, right? So let's say if we do that, and then we instead of randomly select the representative values, and then we just test only the boundary value instead, right? And because you have the input domain as the person age, which is an integer, once you break down into the partition, and then you come up with the test cases around the boundary value here, okay? This is really simple. I don't want to repeat again, okay? Unless you have any question, feel free to ask me. All right, decision table, okay? So sometimes the input number to the function may be, how can I say, there are different types of the input. It could be range, it could be what is that? The true false boolean. Okay, it could be string character. So that we need to apply different testing technique to it. Okay, and sometimes there are conditions, right? Let's say the username, the input is a string, the password is also a string, but when we check, it's not about whether username contain some certain types of the character or not, but it's about whether the username match the database or not, and the password match the database or not. So right now, it becomes a condition. We want to test the conditions of both inputs, right? Whether the username is correct, password is correct, and then we can display the home screen. Otherwise, when any of them is wrong or both of them is wrong, then we should display an error message. Okay. The decision table could help you to come up with what are the possible scenarios based on the condition that you have. You just build the truth table here. True, 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 false, false, true, false, false, and then all done. Okay. That's a decision table. Okay, let's say you want to calculate, this is another example. Let's say you want to calculate a standard deductions of the tax, okay, taxable income. Sometimes different countries, different government, apply different conditions, right, to apply the tax, okay? This is an example. Let's go through something together. If you are single, if you are single, that means you have no spouse at all. If you are whether you are age over 65 or not, okay, no, that means you are young, okay. Whether you're blind, your spouse has some disability or not, is someone blind, is your spouse blind? If no, you're gonna get this deduction amount 4,750. If yes, then you're gonna get a higher amount, that kind of thing. This is more like a logic or business rules, okay? Because of the condition here is really complex, right? So that's why you really want to build a decision table to help you come up with the test cases. Then you know the scenarios. Oh yeah, when the someone is single and young, with and his or her spouse is not blind, then they're gonna get this kind of amount A, B, C, D. Okay, decision table really helps you here. Yeah. Okay. Next step, next example, loan approval decision table. Okay. Let's say you want to test a loan approval system, and the loan approval, the loan application approval decision really depends on the credit score and the income level. Okay. And here is an examples of the decision table, right? If the credit score is high, income level is high, then the expected output could be approved. If the credit score is high, income is low, then it could be a reject one. Okay, and so far and so forth. Okay, yeah. All right, next example. Let's say you want to test online shopping cart discount. Okay, sometimes you have different types of the membership. If you are a regular membership but purchase amount greater or equal than 100, you're gonna get 5%. If you are a regular member but the purchase amount is less than 100, you will not get any discount at all. However, if you are premium, okay, purchase amount is greater than or equal 100, you get 10, otherwise 5. Okay, so based on this kind of the requirement, you can translate into a decision table to help you what are the possible scenarios that you really want to test, and then you just derive the test cases. Make sense? Yep. Okay, the last technique, which is really difficult, okay, category partition testing. Okay. So category partition testing was invented in 1988, okay? And it is a technique to efficiently test the combinations of the input in a system by categorizing them into different equivalent classes and then select a representative values, okay? All right, I really want to say that this is just a technique. The way you test whether it is comprehensive or not, it really depends on you. Okay, where in real world scenarios you want to test as much as possible so that it will not trigger any errors. All right. Okay, so what is the difference between equivalence partition testing and category partition testing? Okay, so equivalence divide the input domain, okay, into the class, but the category partition only focus on the combinations of the input. All right, so let's say, okay, go back to this one. Let's say, yeah. So let's say, what is that? When you think about the equivalence partition testing, I give you examples about the leap year. Okay, so the input is the range, still the input range, and then with a given range, you divide into the partition. Okay. However, for the category, you have input can be something. Okay, it could be a string, it could be number, but the number itself has its own meaning. Okay, whether a username, some username match the database, and then it becomes true, right? Because the username is valid and the password is valid, or the credit score is above a threshold, then it is considered as true, yeah, that kind of thing. All right. Okay, the step here. You first identify the testable input variables, understand the characteristic, identify the constraint, generate the test frame, and then generate the test cases. Easy like that. Okay, let's take a look at the example together so that you understand better. Okay, let's say this is just a user registration form or user login form. Yeah, user registration form. And then you want to detect, whether the username is at which size, the short one, medium one, or the long one, or whether the password is weak, medium, or strong. All right. And then you define some certain criteria about the strangeness of the password, right? That weak, it means that they are all lowercase, but if you mix something, it's considered as medium. However, when you include the special characters, then you consider it as a strong. And then the user registration form should pass, okay, should go ahead, proceed to the next step if, okay, if it is a long username and the password is strong, okay. Only this condition we can move to the next step. Otherwise, no. Okay. Let's do it together. First, you identify the independently testable input variables. And in this case, it is username and the password. Make sense? And then you want to understand the characteristics of each variable. Okay. So you know that with the username, you have three potential values here, short, medium, and the long. With the password, there are three potential values here, weak, medium, and the strong. Okay. And then you identify the constraint among the choices. Either invalid username and the invalid password is considered invalid at all the time. Okay. So it will never be valid. Okay. And then because what is that? You have three scenarios here. You have three scenarios here. You generate the test scenarios, right? Three, okay, times three. Then how many you have in total here? You have 9 valid test frame or the test scenarios. All right. And then you can come up with another one invalid test frame as well. So in total, it becomes 10 test frame. Okay. Then once you know all of the combination, right? 3 times 3 plus 1. You have 10 scenarios. Then you build the decision table, okay? Whether the username is short, weak, short, medium, short, strong, all of the possible combination, okay? And then you know the combination and then you derive the test input, okay? Come up with the test input. For example, the username is short ABC and the password is weak because lowercase, okay? ABC. The expected output, it means that false, not allowed at all. And there is only one scenarios here that is allowed. Okay. So in total, basically this is help you. Okay. This is a technique to help you first, okay, come up with the test scenarios, come up with the test cases, the test input, and then what would be the expected output, write the assertion function, and then test your own code. Make sense? Okay. So you're gonna apply all of this technique in the assessment form, okay? Just FYI, yeah. Christmas discount, okay? We want to, this is the spec, we offer a discount during Christmas. If it is a Christmas, we give 15% discount if the total amount of the order is at least 500. If it's not Christmas, then no discount at all. All right. So what is the first? Let's do it together. Identify the independently testable input variables here. So the first one is the date. Is it Christmas or if it's not Christmas, right? The amount, okay, whether the amount is greater than 500 or not, that kind of thing. All right. So once you know understand the characteristic of each of the variables, then you, yeah, as I just mentioned like few seconds ago, okay, the date, whether it is Christmas or not Christmas, and the amount is actually 500 or less than 500 or not 500, that kind of thing. Actually, it should be just not, but it should be less than, okay? Identify the constraint, all right? Identify the constraint among the choices. No constraint for this case, okay, which is good. Let's generate a test frame because the date has two options, amount has two options, two potential scenarios. So in total, we can generate four valid test scenarios and another one invalid test scenarios. All right. So in total, you got five. Yeah. And then once you break it down into five scenarios, you come up with the test cases. All right. And the Christmas, okay, 500. On the Christmas day, the input amount is 500 and then you get 15% discount, okay? And because at least that means it could be 501 as well. Actually, I should not say not, but it should be less than 500. And the test input could be 499, right? Okay, makes sense. And this is also 499. Yeah, makes sense, everyone. Yeah. Okay. Any questions so far? Otherwise, next one. Next one. Okay, chocolate bars. This is a very fun example. I always like this one. Okay, so this is a box of the chocolate. All right, and the rules here. Okay, we are in the chocolate factory. The rule here is that we want to make a package of the total kilos of chocolate. Okay, so this box is 1 kilo, 1 kg chocolate bars. Okay, we have a small bars, 1 kilo each. Okay, 1 kilo each. No, okay, 1 second, 1 second. Yeah, yeah. So we have a small bar, small, only one. Okay, and the big bar here, 5, which is equal 5 kilos. And the logic, okay, here, the rules here is that we always use big bars before the small bars. All right. Okay. Wow. That's a very difficult one. Okay. I'm gonna give you a minute or so, okay, to think about how should we do this kind of thing. All right. All right. So if you remember, we need to identify the independently testable input variables. Okay. And in this case, what do we need? Okay. We need the numbers of the small bars that we have, the numbers of the big bars that we have, and then how many total kilos that we want to make in this box. All right. The box of the chocolate is also variable as well. Okay. And the output, it should return how many small bars that we need to use, okay? Or return -1 if it cannot be done at all right? Let's take a look at this example. We have 7 small bars in the stock. We have 3 big bars in the stock. We want to make 20, okay? The rule is that we need to use the big bars before the small bars, okay? We need to use the big bars before the small bar, okay? Because we have 3 big bars, so how many we need to use the big bar first, right? So how many chocolate do we have now? 15, okay? Because 3 times 5 here, right? 3 times 5 equal 15 plus how many small bars that we need to use to make 20? 5, another 5. Is it possible? Yes, still less than 7. Okay, so the return, okay, the return of this function, it should return 5. Does it make sense? Return the numbers of the small bars to use, okay? If you get this one, can you say thumbs up in the Zoom chat, okay? Or say something, yes, oh good, I got it, yeah. Okay, very good, thank you, all right. Okay, this is clear. All right, let's move on. This is like I try to do some, random testing here, exploratory testing, right? It's not really systematic at all. But the question is that how should we test it systematically? Okay. Okay, let's do it together. All right. So first we know that the input variables is the small, the big, and the total. We all agree. All right. Tick. Now, we want to understand the characteristic of the domain input variable here, right? There are the valid input. What does it mean? So we use all of the small bars to make the package. We use all of the big bars to make the package. For example, right? Let's say we want to make a 5 total kilos, go back a little bit. Okay. Let's say we have 5 small bars. We don't have big bars at all. And then it should return how many 5? And then we want 5. Okay. We have 5 small. We don't have big bar. We want 5. And it should return 5. Do you agree with me? Yes or no? Yes, okay. Another scenarios, we use the big chocolate bars only, okay? That means we don't have we don't have small bars. We have only one bar, one big bar, okay? And because we want to make 5 kilo, so how many small bars do we need to use? 0, right? Because we use a big bar that at only, all right? And this is similar to the previous example that I give to you. We use both the small and the big bars. Okay, let's do it together. Let's say we have 2 small bar, we have 1 big bar, and then we want to make, what is that? 7 kilograms of the chocolate. How many small bars we need to use? It will be 2. Make sense? Okay, we want to make 7, we use 1 big bar, and then we use the remaining small bar 2. However, there are some other invalid input as well, like not possible. We cannot make it, right? For example, we don't have enough bars. Okay, that means what is that? The total is greater than the small and the big bars, that kind of thing. Okay, or not from the spec at all. That's an invalid input, right? Okay, so we know that. Okay, what we can do? Generate the test frame. Okay, we have 3 scenarios. Okay, here. Okay, that's a 3 valid and the 2 invalid. So in total, we got 5. Okay, we got 5. Once you have the 5 test frame, then you can create the test cases. Okay, this is similar to what I did. All right, the same. I don't want to repeat it. Okay, however, is it systematic enough, right? Looks like we already got 5 test frame, test scenarios. Sounds like we are doing great, okay? But we haven't applied the boundary value analysis here, right? We haven't tested the value. What if everyone, what if? Okay, okay, not what if, but the question. Okay, I'm going too far. Okay, let's go back a little bit. Okay, let's say for this partition, okay, this partition, we want to test the big bar only big bar. We have 5 small, 3 big. We want to make 10. All right, uh, total 10. What we can do, we use too big. We don't need to use small, so it should return 0. All right. If you look at this example, right? uh we have small, okay, let's say if you keep it fixed number, we have 5 all the time. But if you change the tree here, okay, change the big bars, okay, and change the, what is that, 10, okay, and the return value, right, the return value, let's say this is requirement, okay, uh you want to make 10, so the return here will be 0. Make sense? Because you use 2 big bar, you don't use the small. And same to this one. also 0, this is also 0, this is also 0. Why we do that? All right, like it doesn't make any sense. Okay, it just returns 0. What does it mean? It is like really redundant. Okay, that's why the question is that which test input should I use? Like all of them, okay, or just one of them, but which one is more effective, right? Is there anything missing? All right. What about the boundary? Why don't we test the boundary? Okay. So the boundary of the big bar here is that whether we have big bar or not big bar, right? Why we start from 3? It doesn't make any sense. Okay. Scratch it. Okay. Scratch it. Get it away. Only big bars, it means that we have one bar or we never have the big bar. Okay. What about we test this one? That looks better, right? Big 0, okay, and then we want 10. What it should return? -1. We cannot make it, okay? We cannot make the chocolate bar, okay? What about another boundary value, right? So we have the small equal 5, the big equal 1, the total, what is that? The total here, let's say 10, okay? Uh, the first one here return -1, and this one, it returns 0, all right? What about another one if I want to return 1, right? If I want to return 1, then the small keep it fixed 5, okay? And the big bar, we have, what is that? 2? No, that doesn't make any sense at all. Okay, anyway, all right, okay. The boundary, okay, so in short, we need to test the boundary. But how can we derive? Okay, that's better example. Let's say if we want to test the small bar only, all right? And as I told you that the small bar, the input range here is that whether we have uh, one bar or no chocolates, no small bar at all, or -1. Okay, let's say we keep everything fixed here. Okay, and only vary this one, right? -1. Okay, small -1, that means we don't have that's an invalid input, it should return -1. Makes sense. Okay, next one, we want to use only like don't use the small bar at all, don't use the small bar at all, so that means we have nothing seriously. Okay, and then we want to use only one small bar. Okay, one small bar, it means that we don't have big bars, we want one, and then we have only one small bar, that's why we use, okay, one small bar. And now so far and so forth, that's 2. Okay, so apologies, yeah, 1 second. So if you want to apply the boundary value analysis, this is an example to apply into this one. Okay, this is only small bar. What if the big bars? Okay, so what you do, you fix, keep the small bar, okay, 0, all right, and then you want to test the boundary here, all right, whether it returns -1, 0, 0, that kind of thing whatsoever. Okay, you want to test here 0, 1, 2, 3. That's the input range of the big bars. Okay, okay, with the 0 small, okay, 0 big, what, and we want total 5, output is -1. Okay, we cannot make it. 0 small, 1 big, we want 5. Yes, we can make it, but we don't need any small bar at all. We have 0 small bar, we have 2 big, we want 10. We don't need the zeros, we don't need to make the 0 small bars at all. Okay, that kind of thing. All right, this is an example. Yeah. So once you apply the boundary value analysis, you can have more test cases, and then rather than only 5 test cases here, then it will be a bunch, and you might be able to detect more bugs because you apply the, what is that, the uh, what is that, the boundary equivalence, okay, partitioning technique. All right, okay, that's all. Last technique, probably last, okay, I guess. Combinatorial testing is a technique to systematically generate the test cases by considering all of the various combinations of the input parameters. So basically, it's just yeah, Cartesian of the product of the set, right? So just combine everything together. Let's say, give an example here. Let's take a look. Let's say you want to test a web application on different combinations of the browser. You consider Chrome, Firefox, and the Safari. You have three operating systems. How many test scenarios you can come up with? 3 times 3 equal 9. Done. Easy. Okay. Three scenarios for the mobile app. Three mobile phones. In total, you got 9. Again, easy. All right. Let's take a look at this one. Network protocol implementation, you got three, okay, message type, request response error, and network conditions at the low bandwidth, high latency, and the packet loss. So in total, what do we need? 3 times 3 equal 9. Oh, way too easy, okay? Test the router firmware by configuring various combinations of the security testing. You look at the three security testing, WPA2, 3, and the MAC filtering, and the network, three types of the network device, network service. How many? 9 again, easy. All right. And the last one, easy, medium, hard, okay? Three options. Player preference, what is that? Hint on off, time limit on off. Okay, so there will be four combinations here. 4 times 3, it becomes 12. All right. Make sense, everyone? Super easy. Yeah. Okay, let's take a look at the ATM operations here. All right. We have three types of the account, saving, checking, and the credit card. We have two types of the transactions, deposit or withdrawal. Sometimes whether the operation can be done or not, right? It really depends whether you have the right balance or not. Let's say you want to withdraw, the balance should be greater than what you really want to withdraw, that kind of thing. All right. So there are multiple scenarios here. Okay, three options of the account type, two for the transaction type, two for the balance, and then in total you got 12. Okay, 3 times 2 times 2 equal 12. Okay, so cheat sheet. Okay, something for you to think about. Boundary value analysis, it is suitable for the continuous input range, input values. Think about temperature, ages, that kind of thing, if you remember. However, some input range can be created as a partition or classes, that kind of thing. There's a conditions in that. There's a range, and then you may want to apply the equivalence partitioning. Okay, for example, the leap year here. But when you have like multiple input variables, okay, you need like to apply the category partitioning. Okay, for example, this is what's that dryer time, right? You want to calculate the total price based on whether the eco mode or the power mode, how much weight is your cloth. 20 kilograms surcharge, okay, less than 20 kilograms, there's no surcharge. How long is the drying time? It depends on the electricity, maybe some discount for the premium user, that kind of thing, premium client, right? So when you have like multiple input variables, lots of conditions, you really want to come up with the categories, right? And then consider all of the possible categories, combinations, and then you apply the boundary value analysis, pick up the boundary test, come up with the test input on the boundary value. All right. Or sometimes you want to apply the decision table. Okay. When just in when you look at the true false. I mean, sorry, when the input values is the discrete value like true false. Okay. So in practice, usually we need to use the combinations of the technique. It should not be like one single alone, but it really depends on you, like which technique do you really want to apply to come up with the test cases. And then you should justify it in the assessment for as well. Okay. So in short, congratulations everyone. We finished the lecture 9 here. Okay. We talk about the black box software testing. We just come up with the test cases without looking at the code at all. And it is really called like a specification based. Without the specification, you cannot even apply the black box software testing. Okay. And one thing that I really want to emphasize is that we cannot exhaustively test all of the possible scenarios. Okay, the input space is really large, but the key question here is that how can we come up with the test cases or the most effective test suite that achieve, okay, that has the lowest numbers of the test cases, but achieve the highest code coverage. Okay. And thank you so much, everyone. Yeah, really appreciate. Thank you for your attention. If you have any questions, please let me know. Okay. Yeah. Yeah. Thank you. So one, maybe I